Okay, so section 6, again, we're looking at a way to apply some of the other information we've talked about to a normal situation so that we can approximate, estimate, or look at some of the data in just a slightly different way than what we've been doing. Maybe we can look at a situation we weren't able to look at before and look at some of the probabilities that are associated. So it says in this section, we present a method for using a normal distribution as a way to approximate to binomial. If the kids look at these formulas, n times p is greater than or equal to 5, and n times q is greater than or equal to 5. If those conditions are both satisfied, then probabilities from a binomial probability distribution can be approximated reasonably well by using a normal distribution. Okay, mu will equal n times p. Standard deviation will be the square root of npq. And we did some of those in the previous chapter where we were calculating based on those kind of shortcut values, if you will. Because a binomial probability distribution typically uses only those numbers for the random variable x, okay, remember these were discrete values, while the normal approximation is continuous, we must use a continuity correction with a whole number represented by the interval from x plus or minus 0.5. So it's what I also call kind of a fudge factor. Okay, we have to be able to manipulate that area just a little bit more so that it's more suitable for what we're trying to describe. Okay, and I'll show you what that looks like in the problems here in just a little bit. Okay, so if n times p is greater or equal to 5 and n times q is greater than or equal to 5, then the binomial random variable has a probability distribution that can be approximated using those formulas. So I'll show that when we go through some of these in just a minute. Okay, down the bottom, here's kind of where that fudge factor, that continuity correction comes into play. Okay, so they're going to use some terminology, and be careful about the terminology. Okay, because what this terminology does is it identifies greater than, less than, or between situations. The same situations we've been dealing with all chapter long. So if the problem reads at least some value, in this case at least 20, that means 20 and above. So it's a greater than problem. Okay, but notice what the continuity correction has to do. We're going to move our value away from the shaded region 0.5 if it includes the number. Okay, now if it just says more than 120, then that is strictly a greater than. It should say, let's put it like this. Okay, this is at least is greater than or equal to. More than 20 is just greater than. Okay, so if it has an equal sign, we're going to add, or we're going to go 0.5 away from the direction of the arrow. Okay, so we're going to go 0.5 away from 120. So we're including a little bit extra to take care of that, the actual value, the equal sign. Okay. On the next part where it's only greater than, we don't need to worry about the equals part. So we're going to go 0.5 in the direction of the shading. Okay. Down below, these are the other two. At most means less than, equal to. Okay. Fewer than means just less than. Okay. And then exactly means 120. So again, look, does it have an equal sign or not? Okay, if it has an equal sign, go 0.5 away from the shading. add 0.5 onto it. So I want to go left of 20.5. Here I'm going to subtract 0.5 in the direction of the shading, which is left, 119.5. Notice that when it's equals, okay, it's a between problem. Yeah, add and subtract 0.5 onto the number, and we want to find the probability in between those values. So this might be a little bit confusing, okay, but I'll try to point that out when we look at some specific examples here in just a minute on what role that will play, okay. The first part of the questions that you're going to be doing are going to ask you to create the interval for the probability that you're looking for. Okay, so that will play a role. This continuity correction will play a role in what those values are. We're either going to add 0.5 or subtract 0.5, and we're going to look at that greater than, less than, etc. So the terminal vocabulary is going to be pretty important to these. Okay, so let's start at, okay, number 3. Okay, number 3 says find the probability of at least 24 students understanding continuity correction. Okay, at least. Okay, so if that means that I'm trying to find the probability that x is greater than or equal to 24. At least means 24 or more. Now, I need to correct that now. Because of the equal sign, I'm going to change that 24 to a 23.5. Okay, so what that allows me to do then is now I can take the equal sign off of that, and now it becomes more familiar to the problems that I'm working with. Okay, so we didn't have the equal signs when we were doing probabilities in the first few sections. What this allows me to do, this corrected probability, allows me to work with it. I get a value that I can work with in those just like before. Okay, so number 6. Probability that the number of working vending machines in the United States is exactly 27. So I'm trying to find the probability that x equals 27. So corrected, okay, my probability, I'm a corrected probability, okay, x is going to be between 26.5 and 27.5. So you have a probability, and then you have a corrected probability. And that's probably a good way. Write it out what you read first, and then correct it based on what we know the continuity correction will do to it more. Okay? Number 8. Find the probability of no more than 15 peas with green pods. Okay? So probability that x no more than means it could be equal, but more likely will be less than 15. Okay, so I'm going to correct that. Again, what's important here is the equal sign tells you this is the left side shade. Okay, less than is. Okay, so equals means I'm going to go 0.5 away from the shading. So x is now less than 15.5. Okay. 11 through 15 on the top of the next page. Okay, so on 11 and 12 and 13, I think the key here is to identify what the word inclusive, exclusive does. There are no exclusive examples here, but let's talk about what inclusive does. Number 13, find the probability that the number of absent U.S. senators is between 8 and 10. Okay, so inclusive means it has to equal that. Okay, so it's going to look like this. Okay, with the shading in between. Okay, now with the shading in between, the continuity correction means we go away from the shading. So that means that 8 becomes 7.5 and 10 becomes 10.5. Okay, if this was exclusive, okay, then we would go in toward the direction of the shading, and then it would be 8.5 and 9.5. So inclusive means equals, equals means go away from the shading, okay? So wherever that shading is, between, right, left, okay, go away from the shading, 0.5, okay? Exclusive means no equal sign, so we go 0.5 in the direction of the shading, okay? That's all. They're all pretty similar in that regard. Again, lots of betweens on those, so be careful. Okay. 16 through 23, you do not need to do Part A. Okay. Part A is saying that they wanted you to use that table, and I'm going to let you stay away from that. But Part B, you're going to test to see if it fits as a binomial distribution. So you're going to do NP and N times P and N times Q, okay, and see if it fits. And then once you do that, then we're going to find the probability based on that, okay? So number 17, I'm going to grab a piece of scratch paper here. Okay, NP equals 14 times 0.5, which is 7. Okay, NQ is 14 times. Now remember, P plus Q has to add to 1. So if they give you P and you don't know Q, then just subtract from 1. But again, you get the same thing, 0.5 and 0.5. So multiplying those in, you get 7 and 7. So this does fit the model, okay, that's using normal to approximate binomial, okay? So my next step then, I'm trying to find the probability that x equals 9, which when I want to correct that because it's an equals, then it's now 8.5 to 9.5, okay? And I'm going to plug in to find my z-scores. So 8.5, minus. Remember that n times p is mu, and the square root of npq then is your standard deviation. So you're plugging those things into your z formula. So 8.5 minus 7 divided by Okay, so I get a z-score of 0.80, okay, for the 8.5. Okay, when you do the same thing for 9.5, you're going to get 1.34. Okay, so the probability that z is less than 1.34 minus the probability that z is less than 0.8. I got a final answer of 1218. So look them up and subtract them. Okay. So that's what you need to be able to do. Now, again, in this sense, all they're doing is giving you the numbers and ask you to do the work. We're going to do another one like this. But then when they go to the story problems, it's going to be the same thing. Okay. So everything is going to ultimately involve these same steps. Okay. Now, look at number 20. Your first step on number 20. So I want to take NP, which would be 8 times 0.9. And I want to take NQ, and that's 8 times 0.1. Okay, so multiplying, it's 7.2, and you get 0.8. Okay, now remember, both values must be greater than or equal to 5. Since the second part of this did not work on number 20, then you would write down that this is not suitable. Okay, not suitable. Okay, so that will happen on 2 to 3 of these. That's why it's important to test them first. Okay, now, but again, write a probability statement, use the continuity correction, and then use the formulas to find your z-score. Okay, so look at number 23 on the bottom there. And then we'll look at one on the back side as well and see if that gives you enough to get going. Okay, so again, on 23, so n times p is 13 times 0.4. N times q is 13 times 0.6. NP q square root is going to be 13 times 0.4 times 0.6. Okay, so multiplying those, I get 5.2, which is good. And 7.8. Okay, so it passes the test, and it can be done. So I'm going to finish this standard deviation here. I already know what my mean is. It's 5.2. So when I take the square root of 13 times 0.4 times 0.6, I get 1.76. Now, you may notice that, in these examples, okay, we're only selecting one person. We're not using the sample groups that we talked about in the central limit theorem. So we're back to just our basic z formula. Okay, so don't try to divide by the square root of n when you're doing that on the bottom. That's not necessary for this group, okay? So we're trying to find the probability that x is fewer than 3, okay? Fewer than 3. So that's less than 3, where the 3 is not going to be included. So with no equal sign, remember that we go in the direction of the shading, which will change that to 2.5. Okay, so I'm doing a less than problem, which will make that part of it a little bit simpler. Okay, so what I'm going to do now is use the z-score formula, and 2.5 minus my mean is 5.2 divided by 1.76. So actually that rounds to 1.77 is more accurate. Okay, so if I take 2.5 minus 5.2 divided by, that's a negative, divided by 1.77, sorry, leaving you guys out again here. Okay. When I do all of that, I get negative 1.53. Okay. And since this is a less than problem, negative 1.53 is 0.0630. Okay, so again, that's kind of what we're looking at with those. Okay, so those are the answers that we found to those problems. Okay, so don't do part A. Test it, see if it's suitable, and then plug in, find the probability, convert it using the continuity correction, find the z-score, and then greater than, less than, between, do what you need to find the appropriate value from there. So let's look at one that's embedded a little bit more in the story problem. Okay. Let's do this. We're going to stop at number 27. So you can cross out 28 and 29. 24 through 27 are all pretty similar. Okay. 27 says you have a multiple choice test of 25 questions. So n equals 25. Okay. Possible answers are A, B, C, D, and E. So the probability of correcting or getting a correct response by guessing is 1 out of 5 or 0.2. Probability of guessing incorrectly then would be 0.8. So I'm assuming that when I test it, that PQ, or excuse me, that NP and NQ are both going to be greater than or equal to 5. Okay, but I want to estimate the probability that with random guessing that I can get between 3 and 10 problems correct. Okay, so the probability that I can get 3 and 10 inclusively. Okay, now that means the equal signs, that means I go away from the shading. So that 3 becomes 2.5, 10 becomes 10.5. there's my corrected probability. Okay, now I need to calculate my z-scores. Okay, so my mu value, when I take 25 times 0.2 is equal to 5. And sigma, my standard deviation, square root of NPQ, is 2. Okay, so I'm going to take 2.5 minus 5 divided by 2, and 10.5 minus 5 divided by 2. That's just to find my two z-scores. And then since this is a between problem, then I'm going to look up the probabilities and subtract them. So 10.5 minus 5 divided by 2 is 2.75. 2.5 minus 5 divided by 2 is negative 1.25. Okay, so $2.75, 0.9970, 1.25, negative 1056. So 0.9970 minus 0.1056. Okay, so what this is suggesting, okay, think about what your results are saying here. I have an 89% chance of taking this 25 question multiple choice test. I have an 89% chance of getting from 3 to 10 questions correct. Okay, so wow, 90%, but 3 to 10 is still failing. So you're only asking to get from 3 to 10. That's not very much. And so the chance of getting that, I would expect to be a higher value. Okay. But that's how you're going to break these down. Find and designate your NPQ values. Look at the probability that you're being asked to find and correct it. Find mu, find standard deviation, plug into your Z formulas. And then again, is it a between? Is it a greater than? Is it a less than? Find that corrected probability. Okay. So, again, all the sections are kind of related with just little twists to them. So once you become familiar with this procedure, I think you'll be able to go through and do a lot of these. Just make sure that you're applying the little twist in each case. And again, once you get done with a section, try to find those problems on the tests that are like these and answer those while they're fresh in your mind. I will put, there's a couple questions that I'm going to throw out on the test. Like I said, on this thing, you're only going as far as 27. Okay, some of those are going to go quickly. Some of them are going to take just a little bit of time, but I want you to have a chance to practice those before you go to those test questions. So just be careful with those. But I'll put some extra directions on some things regarding the test. But again, just ask. I mean, if you've got anything you need to talk about, things you are still concerning you, if you need another problem worked out, be specific. Tell me the section, tell me the number, and what I'll do is I will write out the solution. I will scan it, and then I'll send it back to you. So, and you can pass it around from there, or anybody that wants it, then it can have access to it. So, but I'll just kind of share them to you through your email so that you can get those. So, um, I'm roughly looking at about 2 weeks. Seniors, since you are going to be finishing up here and checking out that third week from now. You're going to be checking out like your last day is like on Tuesday. Ultimately, your goal should be to have this thing finished by that previous Friday, which is like the um, May 8th or something like that. Okay, so keep that in mind. But everything is there available for you to finish this stuff up. Okay, so the next thing is just to get through it and email me of any questions and concerns that you have. Okay, so thanks.